Welcome back. Today we are unlocking one of the most powerful ideas in algebra, system of equations, graphing. Because in math, every problem is a story. And the moment two lines cross, that's where the answer lies. We'll break it down into three simple cases. One solution when the lines intersect, no solution where the lines run parallel forever, infinitely many solutions when the lines are actually the same. And this isn't just a theory. We'll look at real-world examples, tickets, phone plans, and more, so you can see how intersections become the solution. So grab a pen, get your graph ready, and let's master the simplest way to solve a system of equations. Clear visuals, quick steps, and zero confusion. Let's jump in. Hello, I hope you're doing well. My name is Mahmoud Kiasari and welcome to a new module of Algebra 101 from channel Special K. So today we are going to talk about a new module which somehow is derived from previous modules. If you remember, we were talking about the functions, slope, how we can draw them. We were talking about the coordinate plane. So for some of you that don't have any idea what's going on, I really suggest you to look at the previous video. I'll put the link at the top. So right now we are going to talk about somehow a new concept, which is about the system of equations, which is about graphing. So if you remember from previous slides and from previous modules, we are only focused on one equation, how we can draw that, what does the slope mean, the rise over run, and any other kind of related thing. But right now we are going to put our focus over two lines. We are going to see that what would happen if we do have two lines. Are they going to have intersection? Are they going to be in parallel, or are they going to have all of these points at the same time? So let's start this chapter. So for this one, we do have a couple of different objectives. We're trying to see that do we have any intersection by just graphing them. By graphing, by the way, means that try to draw all of the lines on the coordinate plane. You know about the coordinate plane means that we do have x-axis, it's going to be a horizontal line, and we do have the y-axis. So these two are going to have intersection over on only one point, which is talking about the vertex, and we would like to draw our line or graphing it over this coordinate plane again. So after that, we are going to decide if a system has one, none, or infinite many solution. Explain what the intersection point means in context, because it is important for all of you to understand that when we are talking about intersection, what does it actually mean? Because if you guys remember when we were talking about the linear equations, or when we were talking about the line, I told you that we can apply it into real world. It was about the phone bills, about your some kind of saving money, and there are so many things that you can apply for that. So after that, we somehow expect you guys to locate intersection by graphing, and we can decide if there's one, none, infinite solution, and you guys actually can explain it that what do those points mean actually. So let's start from the core idea. What does it mean when we are talking about two lines are going to have intersection? That specific point, if you guys remember from previous module, each point in two-dimensional settings or two-dimensional coordinate planes has two important criteria: x-axis, which is on the horizontal line, and y-axis, which is on the vertical line. Combining these two is going to give me a pair of numbers that we call it as x and y. When we are talking about intersection of lines like the real world, it means that I have to find one specific point, or maybe infinite specific points. I have to find that point, and if I put that x value inside the first equation related to line, I'm going to have one y. And if I put that specific x into the second one, I should get another y. In the meantime, I'm sure that those x's are going to be the same, obviously, because they are my inputs, and also those y's are going to be the same as well. So at this point, I can say that two lines have one intersection. As we can see, again, a solution to a system is an ordered pair of x and y, as I told you, that makes both equations true. For instance, if you look at this one, you can see that these two lines have intersection over the vertex itself. So graphing over here means that finds the exact location of those are of that one specific point or that specific part that both of those lines are going to have intersection itself. So let's start this part or finding the solution within a story. Imagine that I'm going to start with some kind of a very basic concept, and after that we can apply it over here. Imagine that I am going to the shop, and after that I would be at my house, and after that I go to the shop. My friend is going to the university, and his house is not going to be as the same as mine. But I know for a fact that we are going to meet each other at a point. That specific point that we are going to meet each other is going to be considered as two criteria, one x and one y. So I know for a fact at that specific point we are seeing each other and our x and y's are going to be the same. But it doesn't necessarily mean that both of us are going to be with each other all the time. So we are going to looking for that specific location. We do have three types of condition for each two lines. Either they're going to have one intersection, or they are going to have infinite intersection. For example, my friends and I are going to move from here to the university, and both of us are going to get there side by side with each other. It means that we are going to be together all the time. Or they are going to have no intersection at all. What does that mean? It means that my friend's house and my house are side by side each other. We are going to the university, but we are not going to talk with each other at all. It means that our path is the same, but we are not going to intersect each other at all. So we do have three conditions. One answer from the intersection of two lines, infinite answer where both of those lines are completely the same together, and after that the third one is about the parallel part. It means that both of those lines have the same slope, but they are not going to be together itself. So right now we are going to talk about the first condition. It's going to be about one solution itself. How we can understand that actually we do have one solution? Simple. When you have two lines and after that their slope is not the same. We are not talking about that some kind of the B section or how far is it from the y-axis at the beginning. We are only talking about the slope. We don't care about that. So as long as the slopes are not the same, we can say that those lines have one and only one intersection. Remember guys, when we are talking about intersection, either it's one, infinite, or none. We don't have 2, 3, 4 because we're talking about a line, right? It's not the curve, it's just a line. So at that specific point, I know for a fact that there are two lines. Y is equals to 2x plus 1 and y, another, for example, call that y1, and another one is negative half x plus 4. So right now, I know for a fact that there's going to be one intersection, but here's the question. How I can find that specific point, right? Because that's a real one. So it's very simple. If you guys remember, I told you that I have to find a point that x1 and x2 is the same, and also y1 and y2 are the same. So would it be okay if I say that 2x plus 1 is going to be equal to negative half x plus 4? Why? Because this guy resembles as y1 and this guy resembles as y2. And I know for a fact that x's should be the same, right? So this x is the same as this x, but right now I have to find it. How I can find that? If you guys remember from the previous videos, we were talking about equation and how we can solve them. If I'm going to solve this equation for x, it would be better to put all of the x's in one side and other numbers in another side. So at this point, it would be better to add both sides with half x. Why I'm trying to do that? Because I'm trying to isolate all of the x's in the left side. So I do have 2.5x plus 1 equals to this guy is going to cancel out this guy plus 4. After that, I have to subtract both of them by 1. Why? Because I'm going to only keep my 2.x over here. So I do have 2.5x is equals to 3. And after that, I know for a fact that I have to get rid of that, or I have to divide both sides by 2.5. So x is equals 3 divided by 2.5. If you do this calculation, you will find out that x is going to be 1.2. It means that right now, I found the point, or at least I found the x part of that point that I know for a fact that those y's are going to be as the same as itself. How can I prove it? Easy. Just put this 1.2 inside each of those equations, and after that you have to get the same y itself. So what would happen if I put 1.2 over here? I'm going to have 3.4. If I put 1.2 again over here, I'm going to have 3.4. So right now I know for a fact that this specific point is one and only intersection of these two lines itself. Simple as that. By the way, guys, try to all the time make your equation, oh my god, but try to make your equation as equals mx plus b. If you guys remember, we had different ways of representing a line. Y is equals mx plus b, or 1y subtracted by y0 is equals m times x subtracted by x0. We don't care about that. This is the thing that actually we care. So y mx plus b. Why we are doing that? Because you see in some kind of next slides, actually you are going to have different form of the equation itself. It's not all the time it's going to be like this simple. You have to simplify it. We are trying to have y is mx plus b, because if I do have y mx plus b for one equation and y is equals mx plus b for another equation, that would be easier for me in order to make them equal and find the x value, and after that I can find the value set. So right now and so far we were talking about one condition, which is the one solution itself. Let's move to the next part. So for this part we are going to talk about the parallel lines or no solution. It means that right now I do have two lines while they are parallel. By the way, by parallel it means that both of those slopes are the same, but their y-intersection or the beginning of the point is not going to be the same. So for sure I know those lines are going to move side by each other. So imagine that you have the pillars of your street, and after that you see that both of them are going to move side by each other, but they're not going to intersect. So that's the same scenario. How can I understand it? Easy. As soon as I write them down as y equals mx plus b for both of them, if their m's are the same but their b's are not, I know for a fact that these two lines are not going to intersect at all. So for example, look at this question. I do have y is mx plus b, or m is 3 and b is 1, and I do have mx plus b for another one. M is the same but b is different. So for sure I know these two lines are not going to be the same. They are going to be like this. These lines are not going to be the same. Why? Because they do have the same slope. That's okay, but their intersection or the starting point are going to be different, so there is going to be no solution itself.